Hi everyone. Today's lecture is on design patterns, and well, this is a bit of an overkill lecture because design patterns are normally given and used when you have a bit more experience, and you would appreciate their usage only for larger projects. But it's good to have an idea what they are, to have seen a couple of them, to have heard some of the rest, and just know that there are these things out there that can give you solutions to some problems which you can get when your application or a game become too large. And then some problems can arise from that, and we'll see how to fix some of them. So we are going to be talking what are design patterns, then we're going to take a look at a couple of creational ones, structural ones, behavioral ones, architectural, and then we'll very briefly see design patterns in game development specifically and how they can help you. So yeah, we'll only be having demos for the creational ones because they're slightly easier to understand and show demos of. The other ones are a bit hard to understand, and even if I give you some small example, you wouldn't appreciate how helpful they are in these situations. So most of these are useful when you have like AAA games or like big applications or websites like I don't know, Facebook, Google Plus, Gmail, and all of the AAA games that you can think of probably have a lot design patterns implemented into them. But yeah, for small games or applications or websites, you may not ever need to think about these problems because there is always an easy solution. Imagine something similar is gonna happen. So imagine that in the first course we were writing everything in our static void main method or in the program class, and it was fine, right? So you didn't have the need to create something more complex, add classes, inheritance, and so on. It was all fine because the applications were very, very simple and very short, and we didn't need to know object-oriented programming to write those. So we learned a bit more, and then came the need for object-oriented programming with inheritance, abstraction, and so on. And imagine that this is a level above that as well. So if you have a massive project, how would you create your classes, the connections between the classes, and so on? So yeah, okay, what are design patterns? So these are general and reusable solutions to common problems in software design, and I would really like to stress large projects. Okay, so these are problem/solution pairs within a given context. So in your game or in your application, you can use a design pattern which can help you solve the problem. Okay, they do not provide a finished solution, only a template or recipe for solving certain problems. So these are not connected to put this algorithm in your program and it will work straight away. It's more like if you follow this design or architecture of your application or a game, you can gain something like performance, extendability, reusability, and so on. Okay, abstractions as well, relationships between classes. This can get very complicated once you have 10 or I don't know, 50, 60 classes, and all of them are coupled one with another. You have to use one inside the other, and so on. And once you get a bug or you need to fix something, it's gonna break down the chain. And there are solutions for that as well. Okay, patterns are not concerned with specific implementation as well, meaning that these are very abstract solutions. So if you are in this situation where you have to make something. Here is the recipe, how to fix it, but it's very abstract because it can help, you know, with different problems. So say that you're making a game about Super Mario and someone else is making I don't know, a Facebook clone. There could be a design pattern which will help you both, right? Just depends on the problem and the situation that you're in. So design patterns have a name, problem, solution, and consequences when using them. So it normally comes to trade-offs. So if you use a specific design pattern, it could help you with your code, meaning it's going to be easier to read, understand, used by other people, and so on. But normally that means taking the abstraction of your project one level up, and that could also make it a bit more complicated. On the other side, it could optimize it as well, depending what you mean by optimization, but you know. Alright, so there are many types of patterns, but the most popular ones are creational, structural, behavioral, and architectural. We'll look at each of these with you know, simple examples. The one that I would like to stress a bit more is in the architectural part, where we'll be briefly talking about MVC, because this will be what we'll use in our game Monopoly, which we'll create in Mono game. And also it's going to be important for you because you will need to implement that in your team projects as well. Okay, so creational ones deal with initializing and configuring classes and objects. Structural describe the ways to assemble objects to implement a new functionality. Okay, behavioral deal with dynamic interactions among societies or classes and objects and how they distribute responsibility. So this may mean nothing to you, and right now that I'm reading it, I would just rather know the first word, and that would be more explanatory than the explanations itself. So creational deals with creating objects, structural of the structure of your application or a game, behavioral, how your classes behave and interact with each other. Architectural are a bit more abstract as well, meaning it just gives you a structure not only of your, you know, classes and inheritance and so on. It's more about the general design and architecture of your project and application. So we'll look at those, and I'm sure that you'll recognize some of them when we see them. All right, creational Singleton. Has anyone seen Singleton or have used one? Yes, I'm sure that all of you have, even if you didn't know that you've done that. So, okay, so Singleton is when a class needs to have a single instance throughout the whole application. Okay, so now that you've read this sentence, can you tell me something similar that rings a bell? A class that needs to have a single instance throughout the whole application. Okay, so static class. So this here, solution for C#, create a static class, and this is what you have to do if you need to have a class which is, you know, just instantiated once. All right, examples. The calculator is a good example. The console is another example. And here I would like to give a short demo, which is going to be how to create a class if you don't have the static keyword. How to create a Singleton class if you don't have the static keyword to use. So yeah, let's get into it. So this will be probably the first and only lecture, as far as I know, that I will not be writing any code. I will just be going through it. It's already written. Because there is no point in writing the code here. It's just simple examples that you need to have. All right, so something in a game, that's what I was thinking today when I was writing this. So something in a game that you need only once. And I was thinking about save and load logger, where you can click save and it's gonna log your status and then you can load and so on. And this is gonna be static, but instead of just putting here static and using it this way, I would like to implement it the way you would normally implement it in any other language. All right, so we have a private static read-only field, which is save load logger, which is going to be, is this the first thing that I need to explain? Yeah, so the point here is that I instantiate the logger inside the class so that I can use it. Okay, and I am going to use it through this property which is called instance. Okay, so instance we just have get, and this get returns logger. So this is what I instantiate. So already as soon as I have this class, it's gonna be thought of as the instance of the same class. Okay, so this is the same as static, but normally when you have static you don't need to instantiate it. Well, here instead of instantiating it, I'll just say, well, this class is gonna have its own logger inside the class. Okay, so what do we have? We have a list of strings which is called states, and let's think about that these are really this is really some information about your game. Say which level you're on to, how many lives you have, and so on, and we'll just keep them as strings. Okay, we have a private constructor here which just instantiates the list of string. Can you tell me why is it private? So I mentioned, I think in one of the first lectures of this course, that you can make private constructors, but you will very rarely see someone do so. So can you tell me why is this now private? Yes. Okay, so that we cannot make a new save load logger outside the class. So here I already have it, right? I already have it here. I instantiated it with this constructor, but it's private because I don't want anyone else to be able to use it. Okay, and now how do we use this? So if it was just a static class, it will be fine. I just straight in use it. I don't have to instantiate it or anything. Here I actually have to create a reference to the instance, which is going to be where I save and load my in this case levels. Okay, so logger.save. I don't think I've shown this, but we have a simple method save which adds something to the states, and we have load which loads the very last one that we've saved. And if we want to access some of our order saves, this is by giving an index, and this is exactly what we do. So we give a reference to the instance in my save load logger class. So we save level 1, level 5, level 15. As soon as I say console.writeLine logger.load, I should be getting the last one. So this is level 15. Okay, if I want to say a specific one, just put an index in and see it there. So let me check something for my solution real quick. I want to make this current selection, apply, and let's run this. And this is what we get. So the first one, load, is for the last save that we have, and we can access one by index as well. So if you have to do something like this in C#, just use static, and that means that you've used Singleton. Okay, is that clear? That's probably the easiest one because you've seen it. Yeah, and it doesn't really explain how is this helpful and so on. But once we get to the more complicated ones, I guess you will start to understand. All right, the next one is factory methods. So a problem we have: a framework needs to standardize the architectural model for creation of objects. So let's say that you have objects that you have to create, but in my program class or in my main method or wherever your program starts, I don't want to instantiate all of them with the keyword new and then adding like 50 parameters and so on. So this is something that will simplify creation of objects. Okay, so let's see the demo first, and then we are gonna go back to this one, I think. Right, so let's get here. Before we actually study the factory method, I would like to have a look at simple factory, which is not a design pattern because it's too simple, but it's like one step below the factory method. Okay, so let's have a look. What do we want to have? We want to have a hero, so I've taken this from a game like Warcraft 3 or Dota or whatever you play these days. So I hope that it's very easy to see what's happening here. All right, so we have a standard class hero which has strength, agility, intelligence, along with properties without fields. That's it, pretty much. Okay, so now here I have hero types, which is just an enumeration. Okay, and when I go to my hero factory, this is what we actually want to do. We want to encapsulate how heroes are created, so that if I want to create them and use them inside my entry point, I wouldn't have to type in all of these values and create new weapons and so on. So if you imagine a hero from Dota or League of Legends, it has a lot of things, right? Attack speed, agility, intelligence, strength, damage, what else? Resistance, armor, weapons, list of weapons, actions, whatever. So all of that, I don't want to instantiate it my entry point. So if someone is using it, they want to simply say, well, give me a new hero, and that will be it. Okay, without having to think about 50 parameters and how to instantiate them and so on. All right, so here is what we have. So the only method that we have, which is static, so here we've already used Singleton because this is a static class as well. So the only method that we have is create hero, okay, which is gonna return hero. Okay, and the only thing that we are doing is take a hero type from hero type, so one of these three here that I have, and this method is going to be concerned with creating and giving back the specific hero that we need. So if you want to have a tank, which comes from the hero type, then we make it have more strength, a bit less agility, and almost none intelligence, like mana to cast the spells. We have damage dealer, which has higher agility, and we have mage, which has more intelligence to cast spells. Okay, and if there is if it was not inputted correctly, then we just throw an exception. So how do we use this? We just go in here and we say hero draw equals hero factory dot create hero, and I want to have a damage dealer. Okay, so notice that here at no point I am saying I want to have this specific type of hero with that many with that much strength, intelligence, and so on. So this is hidden. So we encapsulate how are we creating the how are we creating our heroes, and after that of course I can just access them easily, and I'll say that the agility of my agility hero, the draw, is 250. This is the same thing that we had here as well for the damage dealer. Is that clear? Yeah. Okay. Right. So since this is too simple, it's not considered a design pattern, but the next one, which is a step up in abstraction, is a design pattern. So let's have a look. All right. So this is a bit more abstract, where we actually create an interface for creating the the object. So here we only had a single method to do that in the simple factory, but here it will be a bit something a bit more complicated. So you can think of examples like coffee machine, which makes you different types of coffee, you know, when it has to add sugar and milk and so on. You can think of how to make pizza with you know, different ingredients and so on. So yeah, I have the same demo but changed a little bit for the purposes of the demo. So I have the same example with the heroes from Dota 2, but you know, taken a step up in abstraction. All right, so where do we start? Okay, so we have the same hero. This is absolutely the same, but we have now different classes instead of just an enumeration. So we have mage, we have tank. So this is the same as the hero, but you know, you can have different stuff there, you know, different items or compatibility, or you know, whatever you want to have. So we're not concerned with that, just think that the mage is different from the hero. Okay, we have tank and we have damage dealer, so pretty much the same as before, but here we have a separate class. All right, so let's go into the factory. So now we have an abstract class called hero factory, which has a single method create hero. Okay, and from that abstract factory we will have we'll have different factories for each single hero. So let's say that you have barracks for mage heroes, you know, different building for damage dealers and so on. So they're like created separately. So we have like different factories there. Okay, so let's pick one. This one, and it says, well, this damage dealer factory inherits from hero factory, and it has to implement this method but in its own way, right? So I am just saying, well, this method has to be common for everyone. Everyone has to be able to create heroes, but this one specifically is gonna give me a damage dealer with, you know, specific strength, agility, and intelligence. And if we go into the others, which are mage, factory, and tank, we see that, you know, we just implement this interface again. Okay, in the entry point, how is this used? Well, first we have to create the factory, like the barracks in Warcraft, if you wanna think about it this way. And after that we have hero mage, which is going to be mage factory dot create hero. All right, is that sort of clear? Is it clear what we build up from the previous example? Okay, so here we only have an abstract class with a method, and every child factory is gonna inherit this method, but it's gonna implement it its own way. So we are like giving up. So we are having a bit more abstraction here. Okay, presentation. How's that? That was easy so far. Okay. Okay, abstract factory. Now this is a bit more complicated, and I would say out of the ones that we've taken a look at now, this is probably the most complicated one. So it's kind of hard to differentiate between the factory method and the abstract factory, but once you look at the code and the example, I think it will be easy. So we have, instead of just, you know, a single method, which is going to be I don't know, create hero. In this case, we would like to have, you know, a family of related objects or methods inside this abstract factory. All right, intent solution. Okay, so we need. I'll just go into the demo because you know, these explanations are too abstract, and unless you see some code, it's going to be hard to explain. All right. So where do we start from? Let me have a look. Okay, so we have the hero, which is going to be the same. Again, we have tank, we have mage, and they just inherit from a hero the same constructor. Okay, so now the point here is that as soon as I have one factory, which is gonna inherit from this hero factory, I have different methods here, which are creating the elements, in this case heroes, differently. So let's say that I have League of Legends hero factory, and then I have Dota 2 hero factory here. Okay, so each one is going to create the heroes in its own way, right, with its own numbers. And here, instead of just creating a single method, I would like to have them all. So I would like to say, well, you will be able to create a damage dealer, you'll be able to create a mage, and a tank, but someone else can make them differently. So in this case, the Dota 2 factory has the same methods, but they have different functionality here, so, or like different values inside. All right, and these inherit from the hero factory here, which is just an abstract class, so abstract factory, which just says, well, I would like all of the children factories to have these methods, but I'm not concerned with how they implement them. Okay, right. Okay, so let's get to the demo, which is entry point here. I don't have anything, so we should probably do something here. All right. Before we do that, let's say let's say how would we use it. So here I have Ultimate Hero Creator, which is gonna take a factory, one of the two that I have, and it's gonna specifically create heroes on the base of the factory that we've given. This way we hide any functionality that we have, say how do we create them, what kind of properties they have, and so on. I am just gonna give a Dota 2 factory, and this is gonna create me the specific hero without me having to worry about any of the details of the implementation. So the only thing that we're doing here, we take a factory, which is one of the Dota 2 or League of Legends, and this is the constructor. That's quite simple. And then for each of the methods, create specific mage, specific tank, specific damage dealer, we return the corresponding method. But please note that this is very, very abstract here. I am not giving any detail, or I'm not using the specific factory here. As soon as I use this one of these methods, it's gonna find what the factory is. Is it the Dota 2 or is it the League of Legends? And it's gonna create this specific type of hero. So how do we use it? First of all, so let me go into my entry point. So the first thing we want to do is we want to have an ultimate hero creator. So var ultimate 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 hero creator, new ultimate hero creator, and I have to give it a hero factory. So which one do you choose? Is it the Dota 2 or game hero factory? Which one do you want to have? Dota 2 or League of Legends? Dota 2. Okay, Dota 2 hero factory. And now inside here, when I create the ultimate hero creator, I can just say game hero factory, and I can now I can create a specific mage. So we'll say mage, I don't know, Dota 2 mage equals new ultimate hero creator dot create mage. And I'm not so here I am not giving anything in terms of parameters. And this is the cool thing, because As soon as I have this daughter to factory, I am going to be able to create all of the heroes that I want without me knowing anything about them at all. Okay, and I just say, well, give me this hero, and I'll have it without having to look at how to create it. So let's say that in the mage here, which is, or let's say here in the Dota 2 hero factory, let's say that I'm allowed to instantiate the heroes with a specified number of strength, agility, and so on. All of this logic is going to be here. Okay, and if I want to create a mage inside my entry point, I could get some errors. Maybe you cannot have negative health, you cannot have strength more than 1,000, and so on. But when I use it this way with the abstract factory, I'm not concerned about any of that, because it's already taken up the level of abstraction, and I just say, give me one, and I'll have it, with the specified properties and parameters of my initialization. Is that clear? Sort of? No? Yes? All right. Let's get back then. Revisit some of the ones that we have. Okay, so what was Singleton? Okay, so static. If I want to have one which is not static, which is not in C#, how would I do it? Okay, I need a private constructor, and then I want to have the instance of my class inside the class, and this way I make sure that no one is gonna create new classes or new objects from this specific class. I'll just have one. All right. The next one was simple factory. So what was that? You can tell me either the example or whatever you want. Simple factory. Anyone? No? Singleton is fine. Static, and that's it.
You have an object or a class of some sort which returns different type of classes depending on.
Okay, so we have a method which just takes from a number of options and then gives you back the object created already. But in the first case, we did it with an enumeration. You can do it with a string with if-else statement. So say, if hero type is mage, give me new mage. If hero type is something else, give me that something else. Okay, and then we are to factory method, which was different how from the simple factory. Okay, so it's a bit more abstract. Instead of using enumerations, we use different classes, and then for each of them we have a factory which is going to create this specific type of hero, and all of them, since we'll have many different types of factories, they have a more abstract one sitting on top, which tells us what kind of method should they have. All right, and how about the abstract factory?
You don't only have a basic class, you have also an abstract factory and an abstract class. You have a whole factory.
We have a whole factory. Good. Okay, so I guess this abstract factory is easier to explain if we. So let's take another example with pizza, because the one with the Dota and the low is a bit hard to understand, because why would you want to have an application which creates heroes from the different games, right? So let's take the following. So let's say that you are a delivery company for pizzas, okay? And there are many companies inside which inside your platform that people can choose to order pizza from. So something like I don't know, hungry.bg. Do you know this one? Was it gladen.bg? All right. Imagine that here we have only pizza places, and it's sort of like that. So 1, 2, 3, 4, 5. All right. Anyway, so imagine that this is just a pizza place. Sorry. This is full of just pizza restaurants, and what we would like to do is every single pizza place is gonna have their menu with similar pizza types like pepperoni, margarita, and so on. Okay, but each one of them is gonna implement it differently. They are gonna use different ingredients and so on. So we would like to have a factory like this one for each one, right? They're gonna be creating their pizzas differently. So say that this is pepperoni, this is I don't know, margarita. I have no idea how to spell this, so sorry. Hawaii. Okay, but each one of them is gonna implement it, or it's gonna create the pizza their own way, right? So here comes the ultimate hero creator, which is just the delivery company here. The delivery company just takes a pizza place, and then takes the pizza and delivers it to people, and it has no connection of how the pizza was actually made. Was that a bit clearer of an example when you would like to use the abstract factory? Yes, are you sure? Okay. Yes, question.
But should they have the same name?
Should they have the same name? Which name?
Like factory, the hero factory. You can create, for example, with the automation involvement,
Yeah.
and if it's a different name, different kids.
It's if it's a different name, then you can add it with the specifically for each class. So let's say here that I have another type of hero, which is I don't know, help me here, support, public, I don't know, void, or it has to be a hero. So hero, I don't know. Did we say support, or like create support? Return new hero, and here blah blah blah, right? So you can do that, but the point is that everything which is common you have taken one level up in abstraction. Okay. So of course not every single pizza place is gonna have the same pizzas, and this would be very useless otherwise, because you would like to have factories which do absolutely the same thing, and this is not the case. They can make something different, but the point is that the ones that are common are created specifically here, but defined upper in the hierarchy. All right. Oh, we have a lot more time, so this is going to be a short lecture. All right. So I guess the example with the pizzas or similar restaurants is a bit better, because the delivery company needs to just take a pizza. It doesn't care where it's created from, and receive it to someone who is going to use it. Okay, we have the builder, which is now a bit different from what we've done so far, and the point here is that we would like to create objects which have many parameters and or are order dependent. So order dependent means, say, if you have a car, if you would like to make a car, there is a specific order in which you have to create all of the parts and then assemble them together, right? So this is what helps you with that. And let's have the demo for that as well. This one I have not written myself, so I hope that it will be fine for me to go around that. All right, so we have a vehicle, which is the product. Okay, so here we'll be creating, different types of vehicles in this demo. So okay, so we have a vehicle type, which is either scooter, motor, or car. And then we have a read-only dictionary, which has, parts. So the down here, when I say, give me the frame, this dot parts of frame, it will give me the specific frame for the car or from the scooter and so on, which is available via the method show. All right, so what do we have after that? So this is the director inside my builder design pattern, which just describes the order in which we have to build the object at hand. Okay, and after that, every single builder, which do I have a vehicle builder, is gonna follow this same structure as the one here. So in the shop, we have that all of them need to do this. These methods in this specific order, and then every single builder, which is going to be scooter, motor, or car, has to follow all of these. All right, so this is the builder abstract class, which just gives us, it has to have the vehicle and then specifically how to build the frame, the engine, the wheels, and the doors. And now if we go to a specific builder, in this case, let's start with the car. Okay, so we have the car via the constructor. After that, we have a specific frame, which is car frame. We have a specific engine. We have wheels. We have doors, and so on. If we open up the scooter one, it has now the vehicle is scooter, and it has different parameters. Is same for the motor here. All right, so this is motorcycle. Okay. And how do we use this? Well, we just instantiate a shop. We instantiate different builders, and we're not concerned with, again, creating the elements ourselves. This is a bit more, I wouldn't say more advanced than the abstract factory, but they're similar in the sense that you abstract the way and you encapsulate the way you create objects. But here it can be a bit more complicated in the sense that the different parts can be coupled. Say for the engine you have to make something else before that, and so on. So you have some kind of order and some kind of dependency between the parameters to create your general object. And so here, if you look at this, we're once we use this shop or the builders, if you want to have a vehicle like a car or something else, we do not have access to any of this information. We just say, give me a car, and it gives you a car back. And now if I run this, although this is very limited amount of code, we should be seeing all of the specific information here, even though I have not instantiated this way. All right, so what is the other option? So I've this is the first slide that I'll be talking about this, but what is the other option and why is it worse? What is the other option for making the same demo? So let's say that we have the class vehicle and we have the car and so on. Inside here, what would I have to do if I want to have the same functionality? We need to specifically say var car equals new car, and inside here car builder. So where's my car? Okay, so here I have to say vehicle, access it through the constructor and so on, which is gonna expose all of the information that I have for my classes. So inside here, car builder. All of that is gonna be, exposed to the outside world. This way, it's a lot easier. To just say, give me a car and don't worry about anything else. So let's remove that. All right, so those are the demos that I have. I don't have any more. The rest I'll be just explaining, but is it clear what is a design pattern now? It just gives you a way of, say, if you have, different, if you have a problem which is specific to your application, this just gives you a recipe. How can you make it a bit more abstract? How can you make things easy depending on your situation? And yeah, the ones that we've looked at, are for very specific problems, but you can easily make the same or use the same design patterns in your own applications or games. So yeah, okay. After oh yeah, so we have one more, which is prototype. If you remember, this design pattern is pretty much implemented via the iClonable interface in C#. So if you remember on the workshop about graphs, I implemented the iClonable interface, which was just giving me clones of the same graph. So this is very good when you instead of every time instantiating new objects and so on, you can just clone the one that you already have. So an example of this is, let's say that we have a strategy game and we would like to build like Warcraft 3, and we would like to make elves, but all of them are the same, right? They have the same health, attack speed, and so on. They're pretty much clones of each other, right? So I have to make this elf clonable so that I can clone it many times. Is that sort of clear? That's nothing too complicated. All right, so structural, I really wouldn't go into much detail here, and it's very hard to show a simple demo of these because they require a more a larger system so that you can appreciate them. Okay, so the client, what is the problem? The client needs a simplified interface to overall functionality of a complex subsystem. What is the intent? So the intent, or when you use this facade, is going to provide a unified interface to a set of interfaces in a subsystem, or to be more specific, wraps a complicated subsystem with a simpler interface. And let's have a look at the picture first. So let's say that this is the client, which has client. So imagine these are different buttons on your remote control or something like that. So your remote control is connected to this component, and I have to know which ones they are and so on. This one is connected to this and this. This one is connected to this one and this one. So in each case, each client here, or each remote control, knows about the classes it's connected to. Instead of doing that, we would like to create a facade so that each of the clients, or each of the remote controls, if you want to think about it this way, communicates only with the facade, and the facade gives the responsibilities and connections to the other classes in here. So it sort of hides the implementation detail, and it makes it a lot easier. So to have a more, to have a better example here, imagine a universal remote control, which as soon as you go home and you say play movie, it's gonna dim the lights, it's gonna turn on your movie, and as soon as it stops, it's gonna close the window shades, whatever else you want to have. Make popcorn, whatever you want. So instead of you having to press different buttons for that, or instead of you having to have different remote controls to do that, which is going to be complicated, right? I have to press one button, then another button, and so on. You just press the button once, and it does everything for you. So it hides all of the connections you have here. As soon as I press a single button, it does everything that it needs to do, which is given beforehand, so that it makes it a lot easier for you. Okay. The next one, fly weight. So the problem is when you design objects formed by multiple similar smaller objects, and this is very useful when you make maps from tiles, or the so-called tile maps. So instead of creating or having a single, let me zoom in here. So let's say that this square here is one that I have and I have created, and so on. Instead of creating the next one and the next one and so on to create my tile map, I am just gonna copy it and I'm gonna reuse it, right? Instead of just having many tiles and so on, I'll just have one and I'll copy it all over the map. And this way you only hold the reference to your single cell here, one, instead of having different ones. So I'll just say, well, I have this one, and I want to put it in this position, this position, this one, and so on, instead of creating new ones every time when I need them. So this is this really reduces storage cost a lot when you think about it. So I can only have, so this specific map is created with how many? Four objects. So the sea, the grass, the tree, and the path. So here I only use 4 objects, and I only create 4 of them, and the rest I just keep references to and tell you where to put them, instead of how many are there here? 1, 2, 3, 4, 5, 6, 7, 8. 8 by, let's say, 16, instead of creating each one, which is going to be about, I don't know, 100 and something tiles. I am only going to have 4, and I'm just going to put them one next to the other. Behavioral. So a couple of examples here, quite simple. So behavior is, as we said at the beginning, something that relates classes and how they interact with each other. So the way you would interact with let's say the list, it would be very easy to just say for each, or for access it by index, and this is what the iterator does. Okay, it just pretty much in a C# gives you the IEnumerable interface. So as soon as you have a class which has the IEnumerable interface, or when you have an indexer, this is what we call iterator, because we can iterate through the elements of this class. Okay, we have command pattern. So an object encapsulates all of the information needed to call a method at a later time. So this is pretty much exactly what the name says. So instead of so we have a command which is easily accessible, like say console.write. This is a command, but behind the command there could be some complicated implementation which is hidden from you. So we have this command, we can use it, and it's gonna do something for us. So let me zoom in here. Is this too small? This is too small. Let me make it a little bit bigger, so that we can see, and then I'll make it smaller again. Alright, so this is the client. It has a set of commands here: validate, execute, undo, and so on, whatever you think. So let's say that we made the Monopoly game in a C# console application. There has to be a way to for the user to tell us roll the dice, buy this property, and so on, and this will happen with some commands. Okay, so say roll, which is gonna roll the die, move the player. If he landed somewhere, he's gonna do something else. So this is the complicated logic that we hide be between each command, and it handles all of the dependencies or the correct order in execution of sub commands or sub methods. Right, is that sort of clear? Well, command pretty much what it says. It's nothing that complicated. Template defines the base of an algorithm, or the base of a class, leaving some the implementation to the subclasses. And here I have a really good example. So I hope that this is going to be big enough. All right, so we have a worker. Okay, this is the most base class here. Okay, and he has some daily routine, which is when to get up, when to eat breakfast, when to go to work, return home. This is without the to, return home, relax and sleep. Okay, and each worker below is going to define on his own, how is he going to implement these methods here. So they can be different from for each one, right? So let's say that the firefighter has to get up very early, eat some breakfast, then go to work at 8 o'clock and so on. Say the manager, because he's more bossy, he's gonna go later to work. He's gonna have a long break somewhere in the midday and so on. But they all follow the same routine or the same algorithm. It's just that each of them implements it differently, right? It's different for everyone. But it follows these guidelines or this template for the algorithm. Was that sort of clear? Sort of? Yes, but there you have properties, and here we are concerned with an algorithm. So template for an algorithm in this case, okay? But yeah, it's pretty much similar to the abstract classes and the child classes. Each one of them inherits something from the class above, but here we are talking more about behavior, some algorithm that does something for each one. I think I can finish the lecture in about 20 minutes. Would you like some more break, or everything is fine? I can finish it in about 20 minutes more. All right, let's keep going. All right, architectural. Here I wouldn't really want to go into much detail, but the first one is client server. So normally when you make a website, it's going to be shown on your device, or whatever, whichever that is. So you have to connect through the internet with the server, which is a more powerful machine, and you're only going to see some final information, or how is that called? Just the user interface of what's already been processed on the server. So this one is used very commonly in large games. Say the one that is made downstairs, the card game, it uses that same thing. So you have a server, and it handles all of the rooms that you can play in, different players, how they join, and so on. And what you see is actually what only happens to you. So you see the board, you see the cards, and so on. But everything else, like all of the other calculations and algorithms, they're made on the server. Okay, and the one that we'll be using when we make the game Monopoly will be the MVC, which stands for Model View Controller. Okay, so this architecture separates the logic from the data and presentation. So it's like a really good way to think about any application that you were gonna make. So first, you have the model, which is pretty much all of your classes, object-oriented structure, inheritances, methods, and so on. So this is the model, like every single class that you have in your application, which is concerning characters, What else can you have? Characters, maps, and everything else. Just the data of your application. Then you have the view, which is what the user sees. So in order to display the data, there has to be some connection here, right? So say that say that I want to draw a player at a specific position. I have to know what the position is of this player, okay? And so they kind of interact with each other. The controller handles the interaction with the user and the logic. So here is the whole logic of your application. So when you click here, what happens first to the model? So what happens to the player? Have we hit him with an axe? Does he have lower health, and so on? So all of this is transferred here to the model, and then it's drawn so that the end user can see it. So this is a really nice way of separating the logic in your application. So how many of you have started with your game? Has anyone used this? I think I mentioned it. It's on the specification as well, and it's not really hard. I really want to say this. It's not really hard, and it's a really good way to structure your application this way, because once you want to see what the character is made of, how many properties does he have, well, I just go into the model, and then I can see the properties. If I want to see just how to draw them, or how am I drawing the user interface, I go to the view, and then I have to work like most of the work is on the controller because it holds the main logic of the game. So can you tell me one bonus, something really good when you use this MVC pattern? There are lots, but in terms of game development. Yeah, I said that.
You can use different controllers.
Okay, I can just change the controller and keep the view and the model the same. Just like change the rules of the game, or make a different mode or something similar. In the same way, we can just change the view. So the model and the controller are going to be the same. I'm only going to be changing the view, which is say that I want to make the game for mono game, but I want to make it also as a console application. I want to make it into a Unity project. This model is going to be the same, right? This controller is going to be the same. It's just the logic, okay? The only thing that is different is how I draw or how I present the information to the end user. So by keeping these two, I can just change the renderer, and the game is going to work straight up, and you won't have to rewrite it all over again. All right. Any questions so far? Nope. Yep. Nope. Okay. Okay, so I have taken here some examples from our website, and it's at the end of this presentation. It's more like a post on some topic, where the question was design patterns, which one help with what in specifically game development. So let's read a couple of them because I have copied a lot. And if we don't know what they actually do, it's kind of hard to imagine how they're used in game development. But bear in mind, if you need something for the future, like a bigger project or something, you can have a look at these 3 slides and see, okay, so I need to, maybe this one will be helpful, and then you can go on the internet and read a bit more information. And in general, this lecture is more about, there are things which are called design patterns. We are not going to go into much detail about them, but if you ever need them, you know what to look for, right? So this was the idea. So okay, so we have the builder, which I I guess it's pretty clear what you are gonna use it. Let's say that I'm making a Need for Speed game or some kind of a racing game where each part in my car actually matters in in which order it's created, how much how quick is it gonna be and so on. Actually, there was a I think a rocket simulator or something made with Unity. Have you heard about this?
Yeah, Kerbal Space.
Space program, something where you create your own ships and you think and you see whether it's gonna fly and how fast is it gonna fly. So yeah, this is gonna be it. So you have to create the parts in a specific order, specifically give them different sizes and so on, so that it can work. Okay, factory. Create NPCs or GUI widgets based on a string from a file. All right. NPCs, I always forget this abbreviation. Non-player non-player characters. Okay. Sorry. Prototype. The same thing I said with the elf character, like a small fighter elf in Warcraft. We can create many of them, and you just have to have the iClonable interface. The Facade, simplify complex third-party libraries by providing a simpler interface to make your life easier later. Okay, so the Facade was something that hides, connections between, different remote controls, let's say it this way. And if you're using many different third-party libraries, you can easily combine them, or the functionality of all of them in a single class, and then use this class straight away without having to look at the different libraries too much. Okay, flyweight. So this was about the textures, models, tile maps, and so on, where you have similar repeating objects, and you would like to make one which is bigger. In this case, the tile maps. All right, these ones. So the comment maybe encapsulate game functionality as commands which can be typed into a console, stored and replayed or even scripted to help test the game. All right, so Dota 2, anyone? League of Legends, Quake, whatever game you have played, which is slightly bigger. Almost all of them have a built-in console, which is helpful when you want to make something specific about your games, some like specific setting of your game. Yeah, Counter-Strike as well. I was thinking about Quake, maybe Half-Life as well. So all of them have a console which has different commands, and these commands they change the settings somehow in your application. And of course, not all of them can be listed in the settings menu, right? So yeah. The others we haven't mentioned. You can read at those a bit later on. Why is this too much to the right? Okay, so about the state, we are going to be using that in the Monopoly game as well. We are going to have different game states, like main menu state, game over state, replay, first player, next player, and so on. So this design pattern is very often used in games as well. Strategy is a bit more complicated. Basically, when you have an algorithm and you would like to make more algorithms which are similar to the first one, you just take this one, and depending on the current situation that you're on, you have to take different strategies, or meaning implement some of the different sub algorithms of your basic algorithm. Okay, and yeah, that's pretty much it. I would like to show you the two websites which I have taken most of the information from. So the first one is just copy pasted into the presentation, so I won't go there. You can have a look at it later. But the second one is very, very useful because here, they are listed. Say that we want to read something about the strategy pattern, which is here. And here you have the problem, you have the intent, you have some class diagram which simply explains how you should structure your own application. It has structure, it has examples, and so on, which is a pretty good website. And there are a lot here. So Creational, they're probably the easiest. The only ones that we haven't mentioned are Object Pool, and that was it, right? I'm sure that there are more, but these are the more popular ones in here. Okay, structural, we only mentioned Facade and Flyweight. The others you can have a look. Composite is like making a tree, like a graph theory tree hierarchy. So something like hero, and then down here I'm gonna have two main classes of heroes, and down there I can have many sub-heroes and so on. So whenever you use that kind of hierarchy in your application, this is what composite design pattern is about. And we've actually created one, I think, when we were talking about the graphs in one of the previous lecture. All right, so yeah, good website. Have a look at it. If you have the need to use design patterns, then go and have a look. Maybe you will have something to help you here. All right, and that was it. Any questions? No, everything is clear. Okay, thanks.